Okay, quick problem. Solve the proportion. You're going to cross multiply and divide 1. Cross multiply and divide, E is 35. You can take 1ABC2 times 5 divided by 3, it's 5 over 6. Or if you want to do it the old school way, it'd be 1/2 times 5 over 1, that'd be 5 over 2. Divided by 3 over 1, but then it switches to times 1 over 3, so it'd be 5 over 6 regardless. Okay, I'm okay with mixed numbers on these. Here you're finding values, not ratios. Okay, so 7 times 9, ABC 16, divided by 1 ABC 8, that'd be 31 1/2. Okay. So 7 over 1 times 9 over 16, that's 63 over 16, divided by 1/8, so again, that would be times 8 over 1, which is 63 over 2. Okay, that's pretty easy. Now you're going to get in some application problems. I already wrote something, but I explained it very poorly. A lever is an example of a simple machine. A lever is a rigid bar that is free to turn about its supporting point. The supporting point is called a fulcrum. Levers have a great many practical uses. Scissors, shovels, brooms, and bottle openers are examples of levers. Okay, the fulcrum is the supporting point of the lever. Okay, one thing I will say, the longer the distance, the less force it generates. Or the longer the distance it is to the fulcrum, then the less force is on that end. Longer distance is less force. So more distance, less force. Okay? Less distance, more force. There are 3 classes of levers. A diagram of a first class lever is shown. F1 and F2 are forces, D1 and D2 are distances. Using the given values in the table, compute the missing values. I want you to write up here how a fulcrum works because it's going to come up later. Okay? So with a fulcrum, more distance, less force. Okay, it's kind of like a teeter-totter. Could be, well, kind of. Okay, no, not a teeter-totter. It's a poor example. Less distance, more force, greater force, or more force. You get what I'm trying to say. That is why the proportion is F1 over F2 equals D2 over D1. Okay? That is why that works the way that it does. Okay? Alright, so that's why it is inverted, because more distance, less force. Less distance, more force, so it's inverse. Okay? Alright, we're going to set that up. 4 of those. Okay? One thing I messed up, instead of F3, F4, it's supposed to say D1, D2, and I think the assignment has that problem too, so you need to fix it. Okay, so F1 we did not have on the first problem. F2 we had 300 pounds. And then D2, D1, it's 7 over 10. You cross multiply and divide, you get 210 pounds. Okay, on the second problem, F1 was 80. Okay, we didn't have the F2. D1 was 10, okay, D2 is 4. So I cross multiply and divide, I get 200. That's the answer. You just put numbers into the proportion, okay, what you have. F1 50, F2 is 125, and then D2 over D1. D2 I have at 5.5, and then I cross multiply and divide, and it's 13 3/4, okay. 13 3/4. Okay, and then we know F1, F2, it's going to be 65 over 200. And then D2, D1. D2's unknown, and then 6 is D1. So cross multiply and divide, you get 1.95. Okay, next example. Okay. The compression ratio compares the volume of a cylinder at BDC, bottom dead center, okay, to the volume of TDC at the top dead center, okay. Compression ratio, so I can't draw a cylinder worth of crap. Okay. Bottom dead center. Don't draw this, okay. And then the top is a lot. That looks absolute like garbage, okay? But of course the volume at the bottom is wider than the volume at the top. That's why it's so much higher at bottom dead center. Okay, compression ratio compares the volume of a cylinder at bottom dead center to the volume at TDC top dead center. The compression ratio is 9.273 to 1. And the actual volume of the top dead center is 5.482 cubic inches. What's the volume of bottom dead center? So we're going to make a proportion. Ratio, actual. Okay, so the ratio is 9.273 to 1. Okay, now remember, the bottom dead center is on top because it says bottom dead center to top dead center. So that's how it's ratio. And the actual volume, BDC, TDC. Well, I need to find the volume at BDC. I'm given the TDC as 5.482. So you cross multiply and divide that. Divide by 1. 50.83. Okay. And you're measuring volume, so it needs to be cubic inches, inches to the third. Okay, that's your answer. Okay, and then the last one. A car was filled with 15 gallons of gas at a cost of $31.89. A van pulled up to the same gas pump and put 12 gallons in its tank. How much did the owner of the van have to pay for the gas? So we've been solving ones like these all along, okay? We might not have the unit rate, but we do have a ratio. But there's a question you're going to have to ask yourself, okay? As the gallons go up, what happens to the cost? It goes up. So that's a direct proportion. A direct proportion you can line up exactly the way you're used to, okay? Gallons, dollars, or actually dollars over gallons. Dollars per gallon makes more sense, okay? So the rate, we can use 15 gallons, $31.89. And then my cost, I have 12 gallons. So I take 31.89 times 12 divided by 15. Sorry about that, that looks like crap. It's dollars over gallons, okay? So from that first sentence, it might not say per gallon, but it's 15 gallons, 31.89. You could divide and find the per gallon and put it over 1, but you know. So that much over 15 gallons and then 12 gallons. Okay, now I can find the cost. But a direct, we line it up like we normally do in algebra, with like a basic algebra problem. Dollars, gallons, dollars, gallons. So 31.89 times 12 divided by 15. $25.51.